So good morning, everyone. Welcome back to Math 115. Today, we're going to continue on with some more inverse trig, and then we might even dabble in a little bit of 5.1, which is moving into something a little bit different. 5.1 is going to be about proving or disproving trigonometric identities, and also learning trigonometric identities and how to use them. And so on and so forth. So that's what Chapter 5 roughly is about. But before we move on to that, I want to talk some more about these inverse trig functions. Okay, so anytime we have an operation in mathematics, we want to have a way of undoing it whenever possible. The problem with undoing trigonometric functions is that trigonometric functions have a lot of repeated outputs, right? This means when you want to say, I want to go from the output back to the input, you have many candidates to choose from. So you have to add an additional selection principle to say, well, which input are you looking for, right? So for sine, that means we're looking for the input angle, which is between negative pi over 2 and pi over 2. And for cosine, that means we're looking for an angle which is between 0 and pi. Okay, so we want the angle which produces a point on the unit circle who, if we're doing inverse sine, whose height is the given height, right? Or whose, if we're doing inverse cosine, it's whose width is the given width, right? So on and so forth. So that is inverse trig. So far we've practiced, we've seen the notation, we've seen the restrictions that we must impose, and we've seen a few examples of how do we do it. So just to get back in the swing of things, I want to go through these examples from the partner practice last time that I wasn't able to go through. So if you still have your notes, this would be a good time to check your work. So I'm just going to go through these three. I'm going to go relatively quickly. But if you have any questions, just yell out or raise your hand or something, and we'll talk about whatever your question is. Okay, but I should also mention what is up with the homework, I guess. You have 2 homework assignments due today. And I have office hours today, so those 2 things go together. I know, based on the quiz yesterday, that some of you need to come to office hours. I'm not going to personally identify anyone, but I just know that some of you would benefit from it. So please, if you need it, it's there for you. I'm here for you to help you learn. It's you and me versus the class, okay? That's what we're going to do. So just come to office hours if you need it, please. Or if you can't go to office hours, then email me, set up a private appointment, or go to the tutoring center. All right, so let's go through these examples. Are we ready, or does anyone have an administrative question before we start in on content for today? No. That's what I like to hear, a solid answer. Speaking on behalf of the class. Okay, so let's do this one. Arcsine of 1/2. What do I want? I want to find the point on the unit circle whose height is 1/2, and since we're doing arcsine, the height of the point should be 1/2, and which one of these 2 points is going to be the one that I want?
Right.
I want the one on the right because I'm doing arcsine. I'm only looking for points on the right half of the unit circle when I'm doing arcsine. Okay, so I'm doing arcsine, so I want to find a point whose height is 1/2. Okay, so there's 1/2. And now what do I do? Now I'm going to draw in the triangle, okay? And what do I know? I know that this length here is 1 because it's the radius of the unit circle. I know that the coordinates of this point are something, comma, 1/2. Okay, something, comma, 1/2. I know that the y value is 1/2 because I'm doing arcsine. That means that sine of this angle is 1/2. Sine gives you the y coordinate of the point on the unit circle. So that's why I know the height is 1/2. Now what am I going to do? My goal is to find out what is this angle. What is this angle here? So what am I going to do? I'm going to notice that this length is 1/2. And then what do I have? I have a triangle. And I know 2 side lengths of the triangle. What can I do to find out whatever is the third side length? Yes, if I knew this was a 30, 60, 90 triangle, but that's what I'm trying to find out. Is it a 30, 60, 90 triangle? Yeah? Pythagorean theorem will get us this side length as well. So that would be 1/2 squared plus x squared is equal to 1 squared, right? So therefore x squared is equal to 3/4, and therefore x is equal to plus or minus the square root of 3/2. So which one do I want? The positive square root, the positive one, or the negative one? Positive. I want the positive one. Can you explain why I don't care about the negative one?
It's not in the domain for the negative one.
It's not in the range. Wait. Well, it's not really a domain and range question. Really, it's more like this point lives in the first quadrant. Points that live in the first quadrant have positive x values. So the x value cannot be negative square root of 3/2. That would be this point over here. So we know we only care about the positive one. So that tells us that this length here is square root 3/2. What kind of triangle has side lengths 1, 1/2, and square root 3/2? Lauren? 30, 60, 90 triangle. Sorry, not to put you on the spot, but you said it earlier. Okay, so how do I know which angle is the 30 and which angle is the 60? I can see this one should be the 90, but how do I know which one's the 30? Yeah, which side length is the smallest will be across from the smallest angle. So which of these 3 numbers is the smallest number? Well, I think we can agree 1/2 is smaller than 1, so it's definitely not 1, right? So now we need to compare. What is the difference between 1/2 and the square root of 3/2? Which number is bigger between 1 and the square root of 3? Yeah, square root of 3 is bigger, right? Because we'd have to multiply like 1.7 something or something like that by itself in order to get 3. Okay, if you want to know which one is bigger between 1 and the square root of 3, you just have to ask yourself which one is bigger between 1 squared and square root of 3 squared. Well, 1 squared would be 1, and the square root of 3 squared would be 3. Which one's bigger? 3 is bigger. So therefore, square root of 1 is also going to be bigger, smaller than square root of 3. Okay, so square root of 3 is bigger than 1. So square root of 3 divided by 2 is bigger than 1 divided by 2. Okay? So this is the medium side, this is the small side, and this is the long side. So which of angles 1 or 2 is going to be my 30-degree angle? Who can justify their answer? Someone raise their hand and tell me, I believe it is this one because, and then give me reasoning. Yes?
I believe it's 2 because if you have the smaller side, then, wait, no. I believe it's 1 because if the smaller side's pointing, the smaller angle is going to point to the smaller side.
Exactly. That's the reasoning that we want. The smaller angle points to the smaller side. The smallest side is 1/2. The angle which points at 1/2 is this one. So the smallest angle must be here. The smallest angle must be a 30 because it's this 30, 60, 90 triangle. So here we can say this. So I have determined what this picture looks like. Now how do I do, what is arcsine of 1/2 going to be? It's going to be the angle between -pi/2 and pi/2 such that if I put it in the unit circle, it points at a point on the right half of the unit circle whose height is 1/2. I have found that angle. What is it? It's the angle 30 degrees. So, are we happy with arcsine of 1/2 is 30 degrees? No. Better would be to write it in radians. We should give the output of the arcsine function and the arc cosine function in terms of radians. In fact, it's honestly better if you just forget all about degrees as you move forward in math. Okay, radians are just going to be your friend and much more useful once you get used to them. So how do I write 30 degrees in terms of radians? Good, pi over 6. That's one of the ones you should memorize. Okay, now we're happy. This is a number which is bigger than negative pi over 2 and smaller than pi over 2, right? You can tell because the denominator here is bigger than the denominator here. So this number is smaller than that number. Okay, any questions on that one? Okay, I'm going to go through the next one even faster. Always going to draw my unit circle first. Okay, so cosine inverse. I know I'm working on the top half of the unit circle. And I want to find a point whose x-coordinate is negative square root 3 over 2. So that would be a point like over here. And its height is, no, its width. Its x-coordinate is negative square root 3 over 2. And its y-coordinate is a question mark for now. I'm going to draw the angle, which is going to point at that. I know this angle is going to live in the second quadrant. So what do I get? A triangle. Okay, I get a triangle. I know this is 90 degrees. I know this is 1. And I know that this length is square root 3 over 2. Okay, I can see already where this is going. What is this? This is like the side across from the 60, right? So I know that the side across from the 30 is going to be 1/2. If you really want to figure that out using the Pythagorean theorem, you can. But now I know that this angle must be 30 because it's across from the smallest side. This angle must be 60 because it's across from the medium side. And the 1 is always across from the 90. So what have I determined? I know that this angle is 30 degrees. So what then must be this angle? Yeah, should be 150 degrees, right? 150 degrees. Right? 150 degrees. So arc cosine of negative square root 3 over 2 is going to be equal to this angle in radians. Okay? Which, the way that I would go about doing that is not multiplying by like pi over 180, although you can do that. The way I think about it is this. All the way to here is pi, yeah? All the way to there is pi. And how much is this angle? Pi over 6. So this is going to be pi, which would be this angle, minus pi over 6, which would be this angle, which would be 5 pi over 6. That's how I would probably go about doing that. But if you want to go ahead and type or write the degrees and multiply by pi over 180, you can. It'll just be a little bit slower. Once you get a good understanding of like 30, 45, and 60 are pi over 6, pi over 4, and pi over 3, then you can go to any part on the unit circle and just say, look, I know that 2 pi would be all the way to here. And this is pi over 4 less than that. So this would be like 7 pi over 4. Something like that. These are the things that math instructors will be doing in their head, but they never tell you that they're doing in their head. That's how I'm figuring that stuff out. All right, let's do the hardest one. Okay, arc tan of -1. Okay, why do I say that this is the hardest one? Because what is tangent of theta? Tangent of theta will be equal to the ratio of y over x of a point on the unit circle. So why is this confusing? Because I don't exactly know what is the x value of my point. I don't know what is the y value of my point. I just know that the ratio is equal to -1. There are going to be 2 points on the unit circle whose ratio between the y value and the x value is -1. Can someone tell me one of them?
Is it the square root of 2 over 2?
Yeah.
One's positive and one's negative.
What this means is this. Y over x is -1. Therefore, y is equal to -x. Okay? Y is equal to -x. So there are going to be 2 points that satisfy that. There's going to be one down here, which is square root of 2 over 2, comma, negative square root of 2 over 2. And there's going to be one up here, which is going to be negative square root of 2 over 2, comma, square root of 2 over 2. Okay? And if you wanted to figure out how you could find out what those numbers are, you just use this. Y is equal to -x. Plug into the unit circle. You would get x squared plus -x, quantity squared, is equal to 1. Therefore, 2x squared is equal to 1, and x is equal to 1 over the square root of 2, which is square root of 2 over 2, but of course we have a plus or minus. So x is plus or minus the square root of 2 over 2. Y is going to be negative plus or minus the square root of 2 over 2. It just needs to have opposite sign. Okay, so which point is going to be relevant for doing arctan? Point number 1 or point number 2? Which one do we care about? Can someone give me I'm looking for a number and an explanation of why that number. Andrew?
It's going to be 2 because it's between positive pi over 2 and negative pi over 2.
Good. We need the point number 2 because then the angle will be between negative pi over 2 and pi over 2, exclusive. Okay? This is what we had to have for tan inverse, okay? See this? Negative pi over 2 and pi over 2. This is a choice, okay? And it's sort of an arbitrary choice. But this is what we are going to roll with from here on, okay? So tangent and sine, we're looking at the right half of the unit circle. Only cosine are we going to look at the top half of the unit circle. Okay, so let's look at this point here. We want to find the angle, which is going to point at the point square root 2 over 2, negative square root 2 over 2. We draw the triangle. I know that these two sides are square root 2 over 2 and square root 2 over 2. Come on, you know what kind of triangle this is. What is it? Yeah, 2 of the side lengths are the same. That means that 2 of the angles have to be the same. If the 2 remaining angles in a right triangle are the same, it has to be 45 and 45 because the interior angles have to add up to 180. So this is 45, this is 45. So what is arctan of -1? What is it? Someone's whispering it. Negative what? Pi over 4. Good. Okay, so that's how we do arctan. It's a little bit more confusing, right? Because to do arctan, we have to think about the ratio of y over x. Yeah?
Would it be okay if we write it as 7 pi over 4?
Good question. 7 pi over 4 would be this angle, right? Which is coterminal. However, 7 pi over 4 is not between pi over 2 and negative pi over 2. Right? It's bigger than pi over 2. So even though that angle is coterminal, that angle, if we plugged it into the tangent function, it would give us -1 as a result. Right? It would give us -1 as a result. But this is the whole problem, is there's infinitely many choices of an answer, and I want to single out one. So I just arbitrarily say, I'm only going to care about the ones that are between negative pi over 2 and pi over 2. So since that one is outside of that range, I'm going to throw it away, and I'll be left with, I'm going to throw away an infinite set of solutions, and I'm just going to stick with one. And that is the one which is between negative pi over 2 and pi over 2. Yeah?
So for questions like this, you must put it in like the simplest like number, I guess, as we put it.
Like if you have a fraction?
Yeah, like what you just said versus like negative pi over 4 versus 7 pi over 4.
Well, negative pi over 4 and 7 pi over 4 are two different angles. Negative pi over 4 is to say I'm going to go clockwise this much. 7 pi over 4 is to say I'm going to go counterclockwise this much, right? They're coterminal, meaning they point at the same point on the unit circle, but they are not the same, right? So in this case, what we want to do is find the angle which points in this direction, and its angle measurement is between negative pi over 2 and pi over 2. If I add that additional assumption, there's only going to be this one, right? Because 7 pi over 4 would be bigger than pi over 2. Pi over 2 looks like this. But 7 pi over 4 looks like this. It's much bigger. So it's outside of the range in which I'm looking. Okay? It's like that question of like, if I ask like, where is Subway? You say, which Subway? And if I say, I don't know, where is the Subway in that strip mall on 2nd Street? You'd be like, it's the 3rd building from the left. Right? You can answer that question now because you're looking in a specific spot. Does that answer your question?
Yeah.
Okay. Any other questions? Okay. Then, here's what we're going to do. We're going to launch into a partner practice here. Okay, and we're going to do something interesting. We already have some familiarity with how to do arcsine, arccosine, and arctangent. Now what I want you to do is use that knowledge on these two problems. So what do we do when we have a composition of functions? Remember, we're just going to work from the inside to the outside. PEMDAS, the very first thing you learned about math. Well, not the very first thing, but one of the things you learned probably in elementary school was PEMDAS. P-E-M-D-A-S tells you the order of operations. Parentheses come first, which means we're going to work from the inside to the outside. Okay, so let's work with a partner on these two and see if we can come up with something here. Liv, would you mind going back and working with Maya? And Caroline, can you come back and work with Alexa?
Yeah, I was thinking that too.
Yeah, because I guess it's, oh yeah, because it's not between the ends.
And B,
That is your.
It gets kind of bad, so just get used to it. I have a bad I can't stop laughing sometimes.
That is true, but wait. I want you to, if you're gonna say that, I want you to motivate.
Yeah, or you'll be like,
Where's the angle zero? Sine of zero the y coordinate of this point is zero. So yes, that's what it's going to have to be. And double check and memorize that this is right. You can draw the integral and you may you know the coordinates of it.
but,
You can determine this.
I mean, Patterson's pretty nice, but I mean, I just got her some blue. Wow, we're having a.
Well, now we need to do this, right? We found out what the integral is. Now we need to do sine inverse of zero, which is to say what? I need to find the angle which is on the right half to move.
Huh?
We find the angle which produces a point right at zero.
Wait,
It's, we need to be, here's the difference. This is referring to the height of this point. When I write sine inverse of zero, I need zero degree.
It's from a piece of
Makes sense, right? What is the other supposed to do? It's supposed to do something.
yeah, then it just
to start feeling from now and get these functions. Right now, I'm not up that familiarity yet. Uncertain.
It's just a great.
And
It's like
we do a lot more practice.
I worked in a restaurant.
You get paid.
Good.
You've been waiting for it. You couldn't be a greeter. You could be a greeter. They'd be like. I'd be scared.
This function.
Wow.
This function specifically for this one. If we start with a number, do something to it, and then immediately undo that thing. Kind of makes sense that we're gonna get that. This one's gonna well, cosine inverse. Cosine inverse, we're looking for a point on each circle.
To pick the speed.
Yeah, so we're on the top half. So we're looking for a point on the top half of the unit circle whose x coordinate is negative 2. So, yeah, so what I point to here is right.
Oh, yeah.
Cosine inverse of, what is cosine of 5/1? It's negative 3/2, right? And then now, we look for a point on the top half of the unit circle whose x coordinate is
Sorry. Yeah, yeah, all people buy things.
So if I start with 0, then I do something. So you'll have right, I'm gonna go back where I started with, right? What happened here? I didn't get back by, I didn't get right. So So what is cosine of 5 pi? Okay, so this one, negative 5, negative. This one, what do we need to do? First thing we need to do is cosine of 5 pi. Do you believe in that? Yeah. Can you explain how you got
You wouldn't do it.
square root of 2 over 2? So now we found the inverse. First one looks good. Okay. And then what's the second one?
Wow.
Well, what we want to do first is that means we have to do the inverse, right? We want to do what's on the other side first, right? So the first thing we should do, I still like the next coordinate. I was going to, we have to find this thing, so we need to draw that. But it's 5 pi over 4, and you have an idea of which direction we're pointing in, right? What is a right angle in terms of radius?
Are basically right next to each other. And you wouldn't be able to in it.
So 90 degrees, if I converted it to radians, would be how many radians?
Yeah, never.
How many radians is 180
So like, are like diamonds like here, or like, they're like bunny
5
stars.
over 4 is more than pi. It's 5 over 4 is pi. 5 over 4 is 45. So we can go all the way over here to pi. And then go an additional.
I like to.
Pi over 4. Second additional 45 degrees. So this is the point that I'm worried about for doing this. I need to find that point x coordinates that will be what is the output of this one. And then I'll need yes, but cosine. Ignore the fact that there was ever a cosine.
Lady?
So, okay, just want to do this. You know where the get a number right now? It'll be x value. And then we're going to try to find the angle, which is between 0 and pi, which has that x value. Right? So we're going to restrict ourselves to the top half of the unit circle in a minute.
I have to lock that
But
up.
for now, we just need to find the x value of this, which you know what it's going to be. This is a 45, 45, 90 triangle. This is going to be negative square root 2 over 2. Negative also. Okay, so.
Yay! Do you want like a gold star or like what? No hassle.
What's the inverse of
For you.
negative square root 2 over 2? That's what we got, but it is inside.
Okay, but
Now we need to find an angle, which is on the top half of the other side, which points at a point whose x value is that x value.
Okay.
Whose x value is that x value.
Sign is zero.
Go to that point.
Okay, sign is zero.
Which is. We all constitute. So this angle is 130.
It's fine.
And then some.
I saw something that was
I'm taking one.
All the way to here would be pi. This much is pi over 4. Take away pi over 4 would be 3 pi.
I have to.
3.
On my.
No, it should be positive, right? Because the answer to cosine inverse should be an angle between 0 and pi. So 3 pi over 4 is an angle between 0 and pi.
Yeah, isn't there like others?
Yeah, but see, I was, okay, it's a 20-day class.
Does anyone else want a little bit of personal help, or should we go over together?
We should just go over together.
Okay. I try to rotate around, by the way, and talk to like everybody. So if you feel like you haven't gotten personal attention from me in a while, then just yell at me.
It's not, it's, you can't, they can't make you say.
Okay, so let's come back together as a group real quick and discuss these. So I had some people saying that this one felt really weird, and I hope I can dispel any weird feeling that you get from this in the following way. We're just going to work from the inside to the outside. So the very first thing I'm going to do is I'm going to completely ignore the fact that I have this here. Okay, I'm just going to completely ignore all of that, and I'm just going to try to evaluate sine of 0. Okay, it's just a function, it has an input, it has an output. The input of the sine function is an angle. The angle 0 radians or 0 degrees are both the same. They point straight to the right. Yeah? So the angle points directly to the right. So here's the angle, oops. Here's the angle 0 radians. And this points at a point on the unit circle, and the coordinates of that point are what? 1, 0. And what is the sine function supposed to do? You would give the sine function an angle. It goes to the point on the unit circle corresponding to that angle and does what? It returns the y value. So we could rewrite this as sine inverse of, what is sine of 0? It is just 0. So we have sine inverse of 0. Now what am I supposed to do? I need to do sine inverse, which is a little bit of a different flavor of thing to do. Let me show you why. Sine inverse is asking a different question. So if we do sine of 0, we're saying, well, the input is an angle and the output should be a y value. If we're doing sine inverse of 0, we're saying the input is a y value and the output should be the angle between negative pi over 2 and pi over 2, which points at a point on the unit circle which has that height. So we are looking for a point on the unit circle whose height is 0 and lives on the right half of the unit circle. That is exactly this point. And we're supposed to say, what is the angle which points in that direction? And what is it going to be? How many radians? 0 radians is the angle which points straight here. Okay, this should, in hindsight, make a lot of sense because...
Wait, I was right.
Good job. This should, in hindsight, make a lot of sense because what does an inverse function do? It undoes whatever the function does. So if I start with a number, okay, and I do something to it, and then I immediately undo that action, I should be back where I started, right? And I'm just going to get 0. So you might be led to think, oh, well, anytime I have an inverse function and a function, we can just cancel them out, right? Wrong. As we saw in the second example, right? It's wrong. Let's see the second. Well, are there any questions on how we did this one?
No.
Yeah, okay. So this one is, again, we're doing the inverse of the function itself. We're going to get back the original input. except for the fact that inverse trig is special. It's not a one-to-one function. So we have to have this additional specification of, well, not only am I going to find the input, it needs to be the input which is in a specific spot. So let's do the following. For cosine inverse of cosine of pi over 4, I'm going to again do another unit circle. And why don't I just copy and paste it now to save myself time. Copy, paste, okay. So first up, I need to do the angle 5 pi over 4 and take cosine of it. So I'm going to ignore all of this crap for now. I'm just working from the inside to the outside. So 5 pi over 4, the way I can visualize what this angle is the following. I know that pi points straight to the left. And 5 pi over 4 is like an additional pi over 4. Okay? An additional pi over 4, which would be 45 degrees. So I need to go straight to the left and also 45 more degrees. Okay? Or pi over 4 more radians. So that points right down here. And I don't even need to really fill this out, but if you wanted to, you could see, aha, it's a 45, 45, 90 triangle. The coordinates of this point are going to be negative square root 2 over 2, comma, negative square root 2 over 2. So what is the cosine's job? It says, you give me an angle, I'll give you the x-coordinate of the point on the unit circle which that angle points towards. This angle points down here. The x-coordinate of this point is negative square root 2 over 2, so that's what this number is. So we can rewrite this as cosine inverse of negative square root 2 over 2. So let me ask a quick question here. Maybe you can see where this is going. The question is, why is this not just going to be 5 pi over 4? Shouldn't the inverse function just undo whatever the original function is? Shouldn't I just get back whatever was the original input?
5 pi over 4 is in the bottom half, but for arc sine we only take from the top half.
Yeah, for arc cosine, the range of arc cosine, namely the output of arc cosine, must be an angle which is between 0 and pi. Are you about to lose your coffee? Okay, the range of arc cosine, exactly as you say, should be between 0 and pi. So the output can't be 5 pi over 4. The output will never be 5 pi over 4 for arc cosine. It must be a number which is between 0 and pi. So what do? We are going to look for another point whose x value is negative square root 2 over 2. Are we okay in the middle here? Okay. So I need another point whose x value is negative square root 2 over 2. But, crucially, this is the x value, but the point must be on the top half of the unit circle. So I want a point on the top half of the unit circle whose x value is negative square root 2 over 2. It's going to be this point right here. Okay, it's going to be this point up here. There are 2 points on the unit circle whose height or whose x value is this. The one I'm interested in is the one on the top of the unit circle, top half. So what is going to then be the value of cosine inverse? I want the angle which points at a point who has this x value. The angle in question can be seen here, which the way I'm going to figure out what this angle is the following. I know that this is a 45, 45, 90 triangle. Therefore, I know that this angle shown here with red must be pi over 4. So the way I'm going to figure out what this angle is I'm going to say, well, pi would be going all the way to here. And I'm going pi over 4 less than that. So I'm going to do pi minus pi over 4, which would give me what? 3 pi over 4. So we get 3 pi over 4 as the answer.
Did you really?
That's 2 for 2.
2 for 2. That's what we like to hear. So, bit of a tricky example, right? The first one kind of makes you think, that, oh, well, I'm just undoing something, so can't I just shortcut this and get the answer right away by just cancel, and we're happy? Sometimes you can, and sometimes you can't. So you have to be careful. When can I do that? I can do that anytime the input is going to be in the range of the inverse function. But since 5 pi over 4 is not a possible output for the cosine inverse function, I should know right away that it's not going to just cancel, because there's no way for cosine inverse of anything to be 5 pi over 4. That's just not in the output set for that function. Okay, so are there any questions on this partner practice that we did? Does this make you feel a little more confident with the inverse trig functions doing this partner practice? Okay, I hope so. All right, then let's move on to this gross-looking table of crap.
This is no good.
Okay, I know it's no good, but I'm gonna go through this slowly. Okay, we just want to understand what is the domain and range. Okay, in fact, I want you to probably just forget about this column. You already know this. We're just going to focus on the domain and range, okay? And let's just focus on the top row first. Okay, so what is the function? Y is equal to sine inverse of x. Someone tell me, what is going to be the input? What is going to be the input of a sine inverse function in terms of the unit circle? Yeah, it's going to be a y-coordinate of a point on the unit circle. So, what are the possible inputs? They are all of the y values of points on the unit circle. What is the smallest y value of any point on the unit circle? Not 0 or negative infinity, actually. Okay, here's the unit circle. Where is the lowest point? It's down here, right? What is the y value of that point? -1. So the smallest possible input for the sine inverse function would be the smallest possible height of any points on the unit circle, which would be -1. And then we can do a bunch of other inputs, right? Which are all of the heights of points on the unit circle up to the maximal height of any point on the unit circle, which is +1, is the highest point on the unit circle, has height 1. So this is how we get the domain of the sine inverse function. These are the collection of, you can rewrite this as the collection of possible heights of points on the unit circle, right? Possible heights. And what is the output of the sine function going to be? We give the sine function a y value, sorry, sine inverse function, a y value. What does the sine inverse function give us back in terms of the unit circle? If we give the sine inverse function the height of a point on the unit circle, the sine inverse function will return back to us what? Lily?
The angle that corresponds with the height of that point.
The angle which corresponds with the height of that point. That's a perfect answer. So, what are the possible angles for sine inverse? It's all of the possible outputs, which will be between -π/2 and π/2. Okay, so the input is going to be the height of a point on the unit circle. And the output is going to be the angle which points at that point and lives on the right half of the unit circle. So the range of the sine inverse function, you already know what the range of the sine inverse function is. It's the outputs. It's going to give us an angle between -π/2 and π/2. Okay? All right, how about cosine inverse? Okay, what is cosine inverse? Well, we give cosine an x value of a point on the unit circle. The possible x values on the unit circle are from -1 is the smallest up to 1 would be the biggest. So the domain is -1 to 1. Yes, -1 to 1. And the range will be from 0 to pi. Why 0 to pi for cosine? For cosine inverse, we do 0 to pi. Why not -pi/2 to pi/2? Why are the angle outputs of cosine inverse different than those of sine inverse? Yeah?
Because there's a x value we're looking for instead of a y value.
Yeah, we're looking at an x value. The possible x values range from -1 to 1. If we use -pi/2 to pi/2, what are the x values of the points on the right half of the unit circle? They're all the positive ones. We wouldn't have an output for a negative input. But we know we can have negative inputs, so we need to restrict our vision not to the right half of the unit circle for cosine inverse, but to the top half of the unit circle. Okay, we just look at the top half. The angles which correspond to points on the top half of the unit circle range from 0 to pi. Okay, this is probably too much information. I don't really want you to care too much about this one or this one or this one. I just want you to be aware that they do exist, and you could figure out their domain and range if you really tried. I believe in that ability for all of you. Tangent will be the last one we talk about. Why is the domain of tangent wonky? -infinity to infinity. Why is that the domain of tangent? Why isn't it -1 to 1 like the other two? Yeah, and why can that ratio be as large as we want? Because we're taking y over x. That's what tangent does, right? Takes y over x. It's possible that x goes to 0. This would cause this number to become unbelievably large. Another way of thinking about this is, what is the domain of tangent inverse going to be? The domain of tan inverse is the range of the original tangent function. And what does the original tangent function look like? Its graph has asymptotes. This is the graph of the inverse of the tangent function. This is the tangent function. What's the range? Yeah, -infinity to infinity, or all real numbers. That's the range of the tangent function. That is why the domain of the tangent inverse function, we're going the opposite direction, right? So the domain is going to be all of the possible outputs for the original tangent function. So the domain is also going to be all real numbers. And the range is going to be the angle between -pi/2 and pi/2, which produces a point on the tangent function who has the given input as a height. Okay, so it's going to give us whatever this question mark is, this input, which would give us a height of x on the graph of tangent. Okay, so lots of different multiple representations of how to visualize these inverse trigonometric functions. So what I want you to remember about this table, okay, what I want you to remember about this table is what is the domain and range of the sine inverse function. It's, I think, easy to remember if you have a strong understanding of what the sine inverse function does. If you know what types of inputs it can take, you can figure out what the domain should be. Because if we're talking about heights of points on the unit circle, you can figure out on your own on a quiz or test, look, the set of possible heights for points on the unit circle is -1 to 1. That's the set of inputs. The set of inputs is what we call the domain. The range is the possible outputs. The output of the sine inverse function is going to be an angle between -π/2 and π/2. So the output range is -π/2 to π/2. So, you know, if you wanted to, you could try to memorize these using flashcards or something like that. But I think what's most valuable is to understand why the domain is going to be this way, why the range is going to be this way, because you have a good understanding of what these three functions are supposed to do. Does that make sense? Okay. I wonder if we should talk about the graph of these functions. I want you to at least see what the graph looks like for each of these functions. So I'm going to draw it for you so that you can have an idea. Okay, here's the graph of sine inverse of x. So what does it do? It's going to put the collection of inputs are going to be the possible y values of a point on the unit circle. So if the y value of the point on the unit circle is -1, what's the corresponding angle? If the y value of the point is -1, then we're talking about like this point down here, right? What's the corresponding angle? What angle points straight down? 0 points straight to the right. 270 points straight down. But -90 is the one we want, right? Because -90 is between -π/2 and π/2. Which one is it? Is -π/2. So the height of the sine inverse function is going to be, when the input is -1, that's the height of the point on the unit circle. The output will be the angle which points at a point with height -1, which is -π/2. Then what's going to happen is we're going to go up to 0, and sine inverse of 0 is 0, right? Sine inverse of 0 is 0. And then at 1, we're going to have height π/2. And the picture is going to look something like this. And like that. Okay, so this is what the graph of sine inverse of x looks like. Okay, how about cosine inverse of x? Well, -1 means that the x value of the point should be -1, right? The x value of the point should be -1. So we're talking about this point over here. The angle which points there is the angle pi. So the output is going to be pi. And then what's going to happen? 0. If cosine of x is 0, then we're talking about the point which is straight up and down, because this point has x-coordinate 0. The angle which points at it would be π/2. So here's π/2. We're going to pass through there. And then at 1, we're going to go down all the way to 0, right? Because the angle which points at a point on the unit circle with x-coordinate 1 has to be the angle 0. So it looks like, if I'm not mistaken, which it's possible I am, I think it looks like this. Or maybe it looks like this. Maybe we should Google that real quick. I don't want to be telling you wrong stuff. Cosine inverse graph. No, I drew it correctly. Yeah. Okay, so they look like this. And what does tan inverse look like? Well, the tangent function has a vertical asymptote at pi over 2 and negative pi over 2. Okay? Therefore, tan inverse is going to have a horizontal asymptote at negative pi over 2 and pi over 2. And it's going to look something like this. Here's negative pi over 2, and here's pi over 2. And the graph will look like this, basically. Okay, will look like that. All right, so that's the graphs of these three functions. I just want you to have seen them so that when you go on to calculus and your calculus professor says, how the hell do you not know what the tangent inverse function looks like? You were supposed to see that or learn that in pre-calculus. Then you can say, actually, I did learn that in pre-calculus, and that looks somewhat familiar. Okay, but I don't need you to memorize like what these graphs look like. I just want you to have seen them at least one time. Any questions on the graphs? We're not quite done yet, by the way. We still got 5 minutes, and I'm going to use it today because I need to. All right, so no questions on the graphs? All right, then final thing we're going to talk about today will be, how do I find the inverse of a transformed trigonometric function? Okay, how do I find the inverse of a transformed trigonometric function? Okay. The way I'm going to do this is the same way that I used to find inverses. When I had something like this, y equals 2x squared minus x all over x cubed minus 1. What was I supposed to do with a function like this in order to find the inverse? Does anyone remember? How did we find inverses back in section 1 point whatever? Yeah, switch the x's and the y's. So make all the x's into y's, make all the y's into x's, and then do what? Solve for y. I'm going to do the same process here, okay? So what am I going to do? I'm going to swap x and y and solve for y. Here's how this is done. X is going to be equal to 2 sine of y plus 1 minus 3, which, by the way, this graph is just the graph of sine with a horizontal shift to the left 1 unit, a vertical stretch of a factor of 2, and a vertical shift down 3 units, right? So that's all this is. So if we want to find the inverse, we're just going to solve this equation for y. Now, how am I going to do that? The first thing I'm going to do is add 3 to both sides. That seems like a no-brainer. And then probably divide by 2. So we get x plus 3 over 2 is equal to sine of y plus 1. Now, how on earth am I going to get y out of the sine function? How am I going to get it out of the sine function? Yeah?
Inverse sine.
I'm going to use inverse sine. Inverse sine, it will get it out. So I'm going to apply sine inverse on both sides. And now what am I doing? I'm doing something and undoing it. So these are going to cancel, provided that what is true? It's 9:43. What's she doing? Come in. Okay.
Wow. You just stereotyped what
Now what happens? We get y plus 1, provided that what? We need to make sure that y plus 1 is between negative pi over 2 and pi over 2. Okay, provided that this is true. And then we can get y equals sine inverse of x plus 3 over 2 minus 1, again, provided that the input of the sine function here is between negative pi over 2 and pi over 2. If it's not, then when we do the sine inverse of the sine, it's not exactly a straight undoing of what we had already done. It's not a straight undoing. Okay, so this is how we do it. We just use the sine inverse function to get it out. We have to be very careful about canceling sine inverse with sine, and we should say, provided that this is true. Okay?
So that's just the answer.
That would be the answer, right? Exactly. So this is f inverse of x. All right, thanks for your attention. Have a great weekend, and I'll see y'all next week. 1 minute early, no less.
Wonderful.